Hi guys, so first one is a difference of squares. So a difference of squares, we talked about a couple things that we're looking for here. We're looking for a difference of squares to have two terms, that they need to be connected through subtraction, and you need to be able to take the square root of the first and last term. So an example of difference of squares would be 25x squared minus 36. So in this case, we see that we have two terms. They're connected through subtraction, and I can take the square root of 25x squared, and I can take the square root of 36. So in this case, what you do is once you've identified it as a difference of square, you open up your two brackets. You say the square root of the first, 5x, plus the square root of the last, 6. And then you're going to have a positive and a negative version of those two binomials. And that's all you do for a difference of squares. So once you identify it being a difference of squares, the factoring is very easy. The next is a perfect square trinomial. So a perfect square trinomial looks like a regular trinomial without a numerical a common factor. The difference here is you need to look at it to see if it is in fact a perfect square. So for it to be a perfect square, you need to be able to, the first and last term need to be positive, which they are. You need to be able to take the square root of the first and last term. So the square root of 9 is equal to 3, and the square root of 25 is equal to 5. And now the middle term needs to always be 2 times the first term squared and the second term squared. So in this case, it's going to be 5. So 5 times 3 is 15 times 2, which is 30. So the nice thing about this is once I prove these three things, all I have to do is say, open a bracket, it's going to be an exponent of 2 because it's a perfect square. I take the square root of the first, so 3x, the sign of the middle, negative, plus the square of the last, 5. And I've completely finished factoring this perfect square trinomial.